or maybe you, is if we have a terminal arm, we've got an x and y value. This is the y, this is the x, and this is the angle, right? So I know that I can, so we've got our formulas that sine theta is y over r, cos theta equals x over r, and tan theta equals y over x, right? And you know you get these formulas on the test. So in the past, we just take a point on the terminal arm and use those values. And then we, of course, we have to find the r. And we can find these ratios. Okay. Well, so what happens when our terminal arm lies, let's start off with the x-axis. So when our terminal arm is on the positive x-axis, okay? Now what we're gonna do for this part, and the reason why we call it the unit circle, is because we're going to draw a circle that has a radius of 1 around this axis. So the radius of this circle, whoops. Do you have a question there? It might help the other students. Marley?
No, I just can't draw a circle.
Oh, I'm sorry. Okay, so for this circle, we call it a unit circle because unit refers to 1. We're not talking centimeters. We're just saying the radius of this circle is 1. Are we good? You're following that the radius of this circle is 1. Okay. So now I want to look at the situation where the terminal arm is on the x-axis. What degree is that? 0, right? Like we don't have an angle. But when the angle is 0 degrees, you can still find sine, cosine, tangent, believe it or not. So let's see what we know about this point. What are the coordinates of this point? So what is the x? How far did it go? 1, because that's the radius. Okay, what is the y coordinate at this point? 0. It didn't go up at all. Oh my gosh, we know the x and the y. Do we know the r? What is the r? 1, because the radius of this circle is 1. So we know x is 1, y is 1, and r equals 1. As such, we can figure out SOHCAHTOA for 0 degrees. Okay, sine of 0 degrees is going to be y over r. What is y? Oh, that's 0 over 1. So what does that equal to? Ooh, isn't that fun? Zero divided by 1. So sine of 0 equals 0. Ben, punch it into your calculator. Is sine of 0 0? Yes, it is. Huh. Okay, let's do cosine. Cosine of 0 degrees. Well, that's going to be x over r. 1 over 1. What's that equal to? Try it on your calculator. Is cos of 0 1? Yes, it is. OMG. Yes. Because the terminal arm is on the x-axis. So the terminal arm is literally on top of the of the start of the angle. There is no angle. It hasn't opened up at all. Okay, and tangent is y over x, which is what? 0 over 1, which equals to 0. So anytime you have an angle that is coterminal with 0 degrees, i.e. 0, 360, 720, 1080, these are the ratios you're going to get. So instead of having special triangles for the axes, we have a special circle. All right, let's look at 90 degrees.
This one.
Please.
I don't know if the drawing is to scale, but like for the hypotenuse, you can see that like the circle is coming like a bit before like the end of the.
Oh, this is just some random point.
Okay.
Yeah. Yes. Okay. So if I look at a terminal arm at 90 degrees, right? So now my theta is 90. What is the x and what is the y? What's the x value? Oh, and what is the y? 1, right? Because it's a unit circle, it only goes 1 up. And what is the r in this case? R always equals to positive 1. Okay. So when we have, so let's figure out what is sine of 90, cosine of 90, and tan of 90. And Luke, I wanted to give you some feedback. Notice that when we write sine, cosine, tangent, it's always the short form. You sometimes write an E at the end of sine. It's just sin. Okay? Sin, cos, tan. Yeah.
How do we use like a gas?
Good question. The question is, how do we use the cast rule for these? The answer is we don't. All right. Sine of 90 is going to be y over r. So if y is 1, r is 1, what's sine of 90? 1. Do you see how I got that, or did I go too fast? Too fast? Okay. If cos of 90 is x over r, that's 0 over 1. What's that?
0.
And if tan of 90 is y over x, we've got 1 over 0. Uh-oh. What's the problem? Yaha. Undefined. Ben, can you punch into your calculator tan of 90? It gives him an error. But what does error mean? Undefined. Okay. Okay, we're getting somewhere. Yes, Mustafa.
Oh, sorry.
Oh, you're just stretching it out. All right, let's do another one. Let's do 180. Okay, what is the point here? Careful. What is the x value? Good, it's -1. So this is how the cast rule takes care of itself, Lila, is because x is -1, y is 0, and what is r? +1 still. Ooh. Okay, so sine of 180, okay, y over r, what is it? 0. Cos of 180. Go ahead and fill those in. Okay, so if I've got x over r, ooh, what is cos of 180? Negative. I've got -1 over +1. That gives me -1. Okay, tan of 180 is going to be y over x, 0 over -1, 0. Oops, I made a mistake. I wrote 0 degrees. That's not true. Folks, do you see any connections between SOHCAHTOA of 180 and SOHCAHTOA of 0? Look at the ratios. They're almost identical. What's the only difference? In the cosine. All right, so let's do SOHCAHTOA of 270. And where do we think we're going to see connections? With which angle? With 90. Absolutely. Okay, let's choose a different color. What are we feeling? We're feeling kind of lime greeny. Okay, we know the x is 0. What's the y value? -1. Okay, and r? Well, r is always 1, Miss Sly. How can you forget? I don't know, I just forget. And let's see, do we find connections with 90? All right, so we're going to get y over r. Do we have connections? Yeah. Hooray. So it's like whenever you have a 0, you're going to have a 0 on the opposite side. But whenever you have a 1, you're going to have a -1 on the opposite side. And with the undefined, if you have an undefined, you have an undefined. So all the tans across the x-axis are the same. Tangent across the y-axis is the same. But the sine and the cos flip-flop. You see that these connections? All right. So on the test, I don't give you a unit circle. Okay, you're going to have to remember how we get these. Okay? So you're going to go back and do some homework, and we will practice this tomorrow. You're going to do some of the homework for question 4. Well, wherever we have a unit circle situation. So the questions you couldn't do for homework yesterday. All right, that is the unit circle.